For science to really work, you need standards you can count on. Perfect, unchanging standards. A meter is always a meter, a second is always a second. But what if the one standard we all trusted for over 100 years to define mass for the entire planet wasn't so perfect after all? So meet the star of our story. It's a cylinder of platinum and iridium, about the size of a golf ball. Its nickname is Le Grand K, the international prototype kilogram. And get this, since 1889, this single object, kept under 3 glass bell jars in a locked vault in Paris, was the one thing that told the entire world exactly what 1 kilogram was. It was the kilogram. But here's where the story gets a little weird. Over the last century, scientists would very carefully compare Le Grand K to its identical copies from all around the globe. And they started noticing something deeply unsettling. The masses were drifting apart. Compared to the average of all its copies, the original, the one true kilogram, was about 50 micrograms lighter. Okay, so 50 micrograms. That sounds like nothing, right? It's literally about the weight of a single fingerprint. But it's not the amount that matters. It's the principle of the thing. If the very object that defines the kilogram is changing mass, then we don't really have a standard at all. It's like your ruler is shrinking. For the science of measurement, this was a full-blown crisis. So that begs the real question, right? If the bedrock definition of mass is unstable, what does that do to all the science that we've built on top of it? The answer? Well, it's actually kind of terrifying. And you might think, okay, so what? A tiny bit off? But no. The problem was so much bigger than just weighing stuff. This one cylinder was like the keystone in a massive arch of science. A tiny flaw here created a massive ripple effect across everything. Seriously, until just a few years ago, a huge chunk of our modern world was built on this surprisingly fragile foundation. So many of our fundamental units, the very language we use to describe the universe, were all balanced on top of the kilogram. We're talking force, energy, power, even our understanding of electric current. It was a giant house of cards just waiting for a breeze. Let me show you how the dominoes fall. First up is the Newton, our unit of force. You can see it right in the definition. It's tied directly to the kilogram. So if the kilogram gets a little fuzzy, the Newton gets just as fuzzy right along with it. And it just keeps going. The joule, our unit for energy, is defined by the Newton. So an uncertain kilogram creates an uncertain Newton, which means our definition of energy itself is built on shifting sands. You starting to see the problem here? And this is the part that just blows my mind. Even the ampere, our unit for electric current, was defined in a way that ultimately traced all the way back to the kilogram. So yes, our entire understanding of electricity was fundamentally tied to the mass of that one little metal cylinder in Paris. How wild is that? So yeah, something had to change, big time. Scientists knew they couldn't base our understanding of the universe on a physical object that could get dirty or degrade or even be destroyed. The search was on for an immortal standard, one that was tied to the unchanging laws of the universe itself. And the thing is, we'd been down this road before. The meter, it used to be a physical platinum bar, just like the kilogram. But back in 1983, we got smart. We redefined it based on the speed of light, a true universal constant that's the same everywhere all the time. The goal was to give the kilogram that same cosmic upgrade. And this really gets to the heart of the change. It's a total shift in thinking. On one hand, you've got the old way, a single artifact, vulnerable, locked in one city. On the other, you have the new way, a fundamental constant of nature, accessible to any scientist anywhere in the universe, and it is eternally, perfectly stable. I mean, come on, it's the ultimate upgrade. Okay, so that's the goal, but how on earth do you do that? How do you replace a physical weight with an abstract number from the universe? Well, the answer is just brilliant, and it takes us right into the wild world of quantum physics. The hero of our new definition is a number called Planck's constant, written as the letter h. It's a cornerstone of quantum mechanics, a fundamental value baked into the fabric of reality. The plan was simple, but incredibly hard. Measure h with unimaginable precision relative to the old kilogram, and then lock it in, fix its value forever, and make it the new standard. This is the incredible machine that made it all possible, the Kibble balance. It works in 2 ingenious steps.
First, in weighing mode, they use an electromagnet to generate the exact force needed to perfectly balance a 1 kilogram mass. They measure exactly how much electrical power that takes. Then, in velocity mode, they move that same coil through the magnetic field at a precise speed and measure the voltage it creates. The magic is how those two measurements connect, allowing scientists to find a perfect, unchanging relationship between a physical mass and the fundamental value of Planck's constant.
Now, this wasn't a quick fix. We're talking decades of work. Scientists all around the world building these amazing machines, refining their measurements year after year. But they finally did it. They nailed down the value of Planck's constant with enough precision to make the switch. It was a monumental day for science, setting a brand new, unshakable foundation for everything that comes next.
And boom, here it is, the new definition. As of May 20th, 2019, the kilogram is no longer that lump of metal. It is a concept, defined by fixing the value of this fundamental constant of nature. What that really means is that now any lab in the world with a kibble balance can create a perfect kilogram from scratch anytime they want. No trip to Paris required. And the transformation this created is just profound. On the left, you see the old system, a fragile, tangled web, all dependent on that one single kilogram. But on the right is the new reality, a beautiful, interconnected, and robust structure where every single base unit is defined by a fundamental constant of the universe. It's more logical, more stable. It's just more perfect.
So, the long reign of Lagrange K is finally over. Our measurements are no longer tied to the fate of a man-made object, but to the very laws of physics. And that just leaves us with this really exciting question. With a foundation this solid, this reliable, what new frontiers of science and technology are we now able to explore?